Okay, for this video, I want to talk about sp2 hybridization. The last video we talked about sp3. This one is on sp2 hybridization. So, for the simplest case, let's look at boron trihydride. Let's see here. There it is. Remember, boron has 3 and only needs 6. Boron is most typically going to violate the octet rule. So it's usually going to form a simple trigonal planar molecule. Let's look at the off-bow diagram for the boron atom. So 1s, 2s, 2p. It's 1s2, 2s2, 2p1. Okay? That is the off-bow diagram that would be the atomic orbital for a boron atom. Now let's look at the hybridized orbitals. That's hybridized orbitals. And what will happen with this guy is we only need the s orbital over here to combine with 2p orbitals in order to have a spot for all 3 of those. And so we are going to end up with 3 sp2 orbitals. And there are the boron electrons in each of the sp2. Okay, what about this guy over here? He's sitting over here empty. He's not being used. What about the electrons coming from each hydrogen? They're going to go into these bonding hybridized orbitals. These are bonding orbitals now, whereas they were atomic orbitals over here. And we can get a hydrogen there, and a hydrogen there. These 3 sp2 orbitals that are formed, if you think about, we know the shape of the atomic orbital s over here was a sphere concentric around the nucleus, and that the p orbitals were kind of dumbbell shaped, and they went in the x, y, z axes about the nucleus. These 3 orbitals are in a single plane and 120 degrees from each other, which is why we end up with boron trihydride being trigonal planar, which means planar means flat, and all 3 of the bonds are 120 degrees from each other. Okay, that is the simplest case of sp2 hybridization.